Hey y'all, let's talk about hotspotting today. So hotspotting is when different nodes in a cluster are experiencing different resource utilization. Very frequently that would be heap, CPU, or disk, but it could also be thread pools. So let's go spin up a cluster. Let's try to induce it. Hopefully we induce it. Once we've induced it, let's check its symptoms and then let's work on resolving it. So today we're going to be following this hotspotting guide. We just need to go induce it a bit before we get to this detecting hotspotting. So let's go create an Elastic Cloud deployment. Hotspot test. Test. Okay. For our deployment, because I want to force symptoms to show, I'm just going to try to keep it pretty small and 2 nodes. I think I'm going to go with 3 nodes. Okay, so let's go with 3 nodes, which means we'll create an index of only 1 shard, so it hits 1 node, or 2 shards, so it hits 2 of 3. And I don't need integration server or enterprise search today, so let's go create that. Okay. Just need to remember my password. I always skip past the screen. Not the right way to do it. Okay, and then that's going to be creating for us. Awesome. Okay, so game plan for today. I'm hoping that we can show the symptoms really easily after this initial deployment creates, that we're going to go create logs and metrics, which we're going to self-monitor so that the data ingests back into the same cluster. That should give us indexing data, and then afterwards we can go check the indices related to that in order to try to force them into a situation that would induce hotspotting. If that doesn't end up working, fallback, we can go look at looking at the Elasticsearch Python client and trying to induce the same problem via bulk. We'll find out. My hope, though, is that we can just do it via logs and metrics. So right now we're just waiting for that plan to finish, which, to be fair, right, like I think it's like a 5-minute, 6-minute spin up, so it's going to be a little bit. While we're waiting on that, let's talk about symptoms. Okay, so while we're waiting for symptoms to develop, the way we're going to do it, if we're looking through this guide, Elastic Cloud handles like all of the hardware stuff, so it's not going to be resources allocated non-uniformly, or consumed by another host, or experiencing network or disk throughput issues, right? Like all of those are totally possible. They're not going to end up being our problem. The problem we're going to investigate and end up inducing is going to be the shard distributions. So shard distribution, I think this shows kind of sufficiently well. Shard distributions is either on a node level or on a particular index level, that the shards related to an index are unevenly distributed across nodes. So when the nodes go to do the write requests, they are proportionally responding, which by itself on the entire node level ends up being unproportional. So let me see, index level. Yeah, so this is what I'm hoping we'll be able to induce, that hypothetically, if we were only talking about one node that had, it looks like this could be 2 shards. Let's pretend the index had 1 shard. That we'll be able to get to that point that we're showing a write queue of 100, and then afterwards, nodes 2 and 3 are going to be quiet, which makes you question what's going on, right? Under here, it ends up talking about stats and blah, 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 this cat shards type of thing. Like, we'll get to that. Right now, we just got to induce it. Okay, so our plan created, so let's go to logs and metrics, and let's say enable. I want it to point back to itself, and we're just going to enable that really quick. I think while that's enabling, though, I may be able to access Kibana. Let's find out. That is why I tried to spin up a 2 Kibana. It looks like it's thinking about it. It's probably because I'm restarting a node that I care about. Awesome. Okay. Sorry, I always zoom out. Okay, so in Kibana, we should be seeing, oh, I just went to stack management. Stack monitoring. We should start seeing, as those nodes are rotating, that some of this data has started ingesting. So we have 3 nodes. Of those 3 nodes, if we click in, we should be able to see our metrics just barely started. And then underneath it, it looks like file V's not up yet, but it's working on its way. Okay. Yeah. Let's just check. Sorry. The alias cat nodes pulls something. Okay, cat nodes, master, blah, blah, blah. So we kicked off our plan last 2 minutes or so. So this should be able to pull for us. And if not, here I'm gonna like grab that string and just go run it in the API console. Oops. Question mark. B equals true. Okay. Uptime 5 minutes. I don't think they've restarted then. Yeah. Well, I wanted this to work. That's okay. Another day. Okay, so we're still waiting for nodes to restart. Which that's chill. While we're waiting on that, let's go look at some of the data is coming through. So when Elastic Cloud is inducing those logs and metrics, it should be coming under monitoring or Elastic Cloud. Let's go find out. Let's go create a data view just so that I can figure out what I'm supposed to be looking for. Allow hidden indices. Monitoring, metric beat. Okay, yeah, like that. So it's monitoring. I'm also pretty sure. Yeah, Elastic Cloud logs 8. If we do, how do I get that? Oh, maybe that falls under that one. Mm-hmm. Okay, cloud logs. Logs and metrics. La la la. I don't want deprecation logs. No offense to them. Okay. So let's go and create this data view. Now I'm pretty sure this data is supposed to be viewable under observability. Yeah, okay. So somewhere between these two, we're just waiting for that plan to finish. Part of me wants to know when those nodes start up. So A node has restarted, A node is restarting, and A node is left to go. Wow, that was a hard sentence to say. Okay. Anyway, so under here we should be seeing streaming new events. I don't really care about garbage collection. To be fair, we're going to have a lot of garbage collection logs because I told it to make the nodes really small. Let's go look at that same thing in Discover. I want to start customizing some things. Okay, so logs and metrics. Type, input type, service type. Yeah. Let's filter in Elasticsearch, and then afterwards, I think I want to know the message, and I want to know log level? Log level. Okay. Put that to the left, and then make it a lot smaller. Ooh. And then, I think it's called logger. Oh, logger. Okay, So it doesn't look like all GC logs come through with a logger. Otherwise, that would have been easy to filter out. Not GC. Last 1 day can become last hour? Last hour. Whoa. Safe. Right. Okay, publishing address is what I was hoping for, which means it's starting to find its cluster state, no joined, some, which I think means our third node is in the cluster. Yeah. Now we just, oh, the third one may be the final one. Our plan may be almost done. I'm not sure what that means. Somewhere in here, plan successful. Okay, that's why. I was like, why is it ensuring a snapshot repository? I was expecting apply plan settings. Yeah, just had a caching issue. Okay, so now we have logs and metrics enabled, and we saw part of those coming through. Obviously here, these are all the FileBeat logs as well. So all 3 nodes are up. They have logs and metrics coming through. We're able to see those log and metrics under stack monitoring, which stack monitoring now should actually tell us that it knows about the FileBeat logs. Yeah, no longer have that yellow banner. Okay. So at this point, we have the data coming through. Now let's go see where that data is coming into. So I never remember how to do this. I know it's index management, but I always end up falling back to the Elasticsearch API, which is my bad. Okay, so I purposely spun up 3 nodes because when you default create an index, it defaults to 1 primary, 1 replica, which means that these 2 indices are unable to spread evenly by themselves across those 3 nodes. And also coincidentally, because this is 4 total, they're also unable to spread evenly across all 3 nodes again. So let me think. If we want to induce this, yeah, let's go remove ILM. So disclaimer, we're going to be doing a lot of things to break it, which default means don't do it on purpose, right? So let's go check its ILM. Okay, so it's not even managed. I forgot what the Kibana one was. Kibana monitoring ES7. Monitoring ES8 has a policy. I don't remember. Let's find out together. How do you remove an ILM policy? The target underscore ILM remove. Has failures. Wow, I didn't do anything. That's cool. It doesn't have an expand wildcards. Maybe it just doesn't take wildcards. Okay. Hopefully there aren't too many of these. So the reason I'm interested in doing this is because while we're ingesting, we'll be able to show heap, CPU, and or thread pool issues. But if we remove ILM, eventually we could potentially be able to show disk. So that was a remove. Post. And then let's make sure that did it. That did it. Okay. La la la. Okay, so ILM's gone. Next, let's see where everybody is. I want a cat indices monitoring. Dot monitoring. Okay, so we knew about .7, we knew about .8. Okay, we're looking, like we're going. Index, help, UUID, rep, docs count. I think that's all I really want to see. Okay, so I'm just going to pull this a couple times to figure out where my data is ingesting. I'm expecting it's going to be V8. I just want to make sure. And we should sort by indexing, because I'm not good at watching otherwise. So I think maybe no docs while I'm checking. Which I definitely expect docs to be inducing. Monitoring. Let's force a refresh. Okay. So line 2 updated. To be fair, all of these are new, so it is definitely possible that we're inducing into all of them, which would be fine. Okay, so 1, 2, 3, 4, 5, 6, 7, 8 is not going to be even, and it looks like the 2 Elasticsearch ones are a little more written to, which makes sense. So if we're going to go play with somebody and force it to look problematic, it's going to be the Elasticsearch ones. Okay, so let's try a small one and see if there's anything to see. Let's update its settings to say that it doesn't, close bracket, blah, 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 that it doesn't have any replicas. Number of replicas. If this doesn't work, we'll look it up in the API. No such index. Okay. And then I should probably just store these. I'm gonna make sure that takes effect. Number of shards is 1, but we don't have any replicas. I guess I should like look harder. Auto expand replicas is 0 to 1. That's fine. And this one also should say no replicas. 0 to 1. Awesome. Okay, so the amount of docs in those indices was really small, which makes sense. It's a test cluster. But let's still see if we ended up with anything to see. Cat nodes. I want to run this. Okay, so heap's low. This heap percent is a little elevated. That may just be transient. It's not transient. Good. Yay! Okay. It is maybe transient. Man. Okay. It looks like node 2 also maybe has a high-ish heap. Let's go check. So heap is not fully the same as JVM memory pressure. Heap is instantaneous, JVM memory pressure is recent. So it's good to check them both. Okay, and then our disk use percent is crazy low. Shards ended up balancing, uptime, the rest of that's good. Okay, so enabling that potentially is not enough just because we're not doing enough traffic. I'm trying to think other than clicking around the Kibana UI, if there's an easy way to induce that. I think we could toggle on and off index settings, but we may need to go create a test index. So let's just go create a test index, and then same as what we had done, let's get it down to 1 shard. Okay, number of shards, 1, and then let's go see if we can, oh, I don't need that. Let's go see if we can figure out how to set up the Elasticsearch Python. Okay, pip install Elasticsearch Python should be installed. Blah blah blah. Let's run in the background tab. Okay, compatibility. La la la. Example usage from Elasticsearch. Okay, so touch test Py and open it in Sublime. From Elasticsearch, import Elasticsearch. Elasticsearch of a URL. Ooh, with an API key. Okay, let's go find our URL. Elasticsearch, copy endpoint. And let's go generate an API key. That is somewhere under management, but I don't know where. Okay, API keys, create an API key. Spotting test. Apply expiration, blah, 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 blah. Good enough. Okay, copied. Okay. And then, let's duplicate this tab. I just want to start by making sure that that works by pulling the cluster health. Cat health? Not cat health. Close to cat health though. That looks the closest. Maybe it's up here. Oh, it was one row above. Ironically, the first result. Okay, somewhere in here, it's gonna look like that. Sorry, I just feel like that answer should be easier. Find me the cluster health API, blah, 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 Python. Okay, so for the client, I guess I should leave it named client. Oh, I didn't even write client. For the client, let's copy this. Okay, wait for status yellow. Just want to try it with defaults. Do we copy? Oh, we don't need that, at least right now. Okay. Python test py. Client is not. Wahaha. Okay. Cool. Yay, we got the cluster health. Okay, so the beginning part of it is working. Now, what did you say to do? So we can create a doc. Okay, so we created a test index called test, but then the second part is that this looks to be doing a single index event. To be fair, Elastic recommends pivoting to the bulk API just because databases are more HTTP bound than they are disk write bound. But I want to break it. So let's do exactly what they're saying to do. Knowing that if we end up breaking it in a way that it ends up inducing like 429ers, for our purposes, that's actually exactly what we want. Okay, let's talk about dogs. It's gonna be they're all gonna be golden retrievers. For dog type in golden retriever. I don't know how to spell. Close enough. Blue healer. German Shepherd. And then for I in range 0 to 100. I think that's how you do ranges in Python. For range. Probably close enough. If not, it'll error on us. Let's start low. 2. Print I of dog type. blah, 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 blah. Yeah, I like that. Okay. So now let's look at our docs. So for a read of doc type, the text, I don't know what a bonsai is. Isn't that a tree? It's a tree. Oh, okay. The message field is going to be, don't you think this dog type is adorable? Oops, star. Star. Yeah. Okay, and the timestamp, let's do it with an @ sign, is timestamp now, and the, not an ID, but the rando, I guess, is I. And our index is called test. I hope if I just remove I, it will auto-generate for me. Okay. Let's find out. Name error. I didn't import date time. Cool. From date time, import date time. Okay. Created. Perfect. Okay. Let's go look at that data. Index management. Oops. Okay, so test exists. Status open. Ooh. Good on them. Oh, I did not know this existed. Man, we could have just copied. Hey, they know to do bulk. That's awesome. Okay. We should have ended up with our mapping. So we have our breed, it's a keyword. We have our message. It's a text and a keyword. And we have our rando. Settings, number of replicas, 0. Excellent. And sorry, I've just never seen the statistics. Oh, it's index stats. Okay. So we have our data. Let's go create a data view to sit on top of it so that we can see it. Doggies. Test. Literally just test is fine. So data view. Discover. Doggies. Probably should have saved that last search, but there is no data. However, date time now, what time zone is that? I don't know. Let's go find out. Under discover, just do today. Today. Okay, so it was UTC. We must have forgotten. Okay. Collateral, obviously. Let me see. Give me a breed. Where is it? Oh. Okay. Make that smaller. And give me rando. I don't see where that column is. Oh. Oh, it's just a number. Okay. La la la. Okay, so I think we're set up that we would be good to go start doing this a little more intense. Let me just make sure. Okay. Don't you think this blue healer is adorable? Oh, we forgot the doggy emoji. This doesn't matter. Sorry. Okay. Being totally focused. I'd be less annoyed if date time now was in my time zone. Date time today in Python. Yeah, okay. Good. Then let's only look in the last hour. Okay. To be fair, what I'm about to induce in Python is basically doing almost denial of service, but totally not against this cluster. But we want to be able to see it, which is why we're purposely doing an index, not bulk event. However, again, highlighting if you're ingesting a whole bunch of docs, you want to do a bulk instead. Okay, so I'm going to say, am I going to say 2000? Let's set up how we would check this. Okay, so under cat thread pools, do I have cat thread pools? Nope, fine. Let's go do it in Discover. I was in Discover. Let's go do it in DevTools. Okay, so under DevTools, I want to set up that what we want to go check is cat thread pool. This command, blah, blah, blah. Ooh. Copy. Okay, do I need to? I'm doing it against a test. Okay, so I want to do it against a write. So I'm not ingesting right now, but we may sporadically see logs and metrics in there. We have node 1 a little bit ahead. Let's do get cat shards of test question mark B. Where is it? Okay, so our one node, one shard is on node 2. And it's only kilobytes in size. Wah, wah, wah. I wonder lorem ipsum. How annoying. Sorry, I think I just write SQL too often, but lorem ipsum. And then let's force that to have to think every time. That cardinality is going to be horrible, which may end up causing Discover to complain later, which would be awesome. Only because we're here to break it, not in general. La la. I guess we could just copy it twice. I don't care. La la la. Okay. Go create. Aww. Should put an F. Can you word wrap me? Okay, what was the problem? Oh. These quotes. Okay. I think I already set it to 2000. I'm gonna wrap that. What was my effect? No thread pool? No thread pool. Okay. So we gained 10 kilobytes up to 19 docs. La la la. Okay, let's go see Discover. It should still load just fine. Last 1 hour. Lorem ipsum's here. Perfect. Yeah. Okay. How many docs is that? 251? That says, oh, I was like, that says 19. I always forget that there's like that refresh delay in order for docs to increment. It's gonna get me multiple times. Okay, I think we're ready. So the callouts of what we're looking to see. So when the nodes go, or sorry, when the Python program is going to write, it's going to be writing individual docs. The reason for that is an individual HTTP request is what shows under the cat thread pools. So we're expecting node 2, which is at the bottom, we're expecting its active pool to increase. The Q max for these thread pools is 10,000. I don't think we're gonna be inducing that today. We'll find out. But we do already see that for historical, since node uptime, that we are almost sitting at a little under 2 or twice as much as the other nodes. So that's on purpose. The reason we chose one node is because, what is it called? Like Elasticsearch desired balance? Desired balance. So Elasticsearch before version 8.6 had a concept of quote unquote balance. That was that if the shard counts across nodes were even, the dev team decided that that was good, but a little bit insufficient because it didn't take into account either disk size and or if a data stream or an index was receiving high writes. So they induced what's known as desired balance. Blah, blah, blah. So desired balance expands that idea in order to account for the writes. So the reason that I made sure that we were one shard for our purposes today is because it can't move that shard and improve the overall balance because it knows that it would just move its problem with it, which is good. Both that Elasticsearch tries to help us and that we are managing to avoid the help. So 8.6 is that divide, wrong tab. 8.6 is that divide, that's what we want to see. The other thing we wanted to see is cat nodes. I'm going to put these in one UI so I don't have to switch. We don't need our version. I don't need our shards. So I'm going to want to know uptime in case we lose a node. So nodes can temporarily overwhelm, in which case like they either won't show in this row, or node 2, like all of these stats may end up like showing as an empty line. That's an indicator of node overwhelm, but a node overwhelm is not a guarantee of it actually exiting or out of memory, which is what the uptime will tell us. So again, if we're able to induce, this is where we're hoping to look and what we're hoping to see. So the only question I'm not fully sure is that cat write thread pool max is 10,000, but we're trying 2,000. I think we're just gonna try 2,000 and see where it gets us, and then afterwards, haha. I don't actually necessarily know or think this does anything, but here we are. Oh, not the first one. I just want to show you a disk issue if I can. Wow, that took me so many seconds. Okay. Breed, message, timestamp, rando. Let's just always try it. Make sure that's not going to be annoying. Created. This may also be annoying in our terminal, but let's do it anyway. And then, I wonder if that's exactly. Okay, if blah 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 does not equal that, then print it. So it's gonna be something like that. And if we start inducing issues, then we'll be notified, but otherwise this is just gonna run. La la la. Let's do it. Okay. 2000. So I'm gonna let it sit here for a little bit. I guess somewhere in there we can just hit enter, see if it tells me that writes are happening, or if it thinks it's keeping up fast enough. We got 1 active. But we do see that count is increasing, so that part at least is going. It looks like the nodes are still sufficiently sized that they are keeping up with that though. So I might have tried to keep it small and still effectively kept it large enough. Did you run? Okay, C, let's go. Downloads, HotSpotting. What did I call that? Pi, test.pi. I wonder if we can run these sequentially. We're all gonna find out together if I hurt my computer faster than I hurt Elasticsearch. We got 1 active. Okay. So we're starting to chug on those completed. It's definitely increasing, but we haven't induced a queue yet. Our heap, that's probably just transient. Part of me wants to go downsize the nodes. Except if we downsize them to 1 gigabyte, potentially anything's gonna hurt them. To be fair, it's a test cluster, and we're barely doing anything against it. Let's do it. But let's do it after. Let's just do this one more time. This is not how you parallel process, just so we're clear. This is just how we're going to be. La la la. Okay, let's just see. Does that get me anything? I mean, this definitely clearly shows what you'd call quote-unquote historical hotspotting, that this is so bad compared to the other ones. Those other nodes showing complete, though, makes me wonder if we're potentially inducing more logs and metrics. Let's check that here in a second. Nope, that's still very low. Very low, relatively. Sorry, it's not incident level. Okay, we wanted to know if we're potentially inducing more logs and metrics. I wonder if we did switch over to bulk requests. No, I need it to show in thread pool. Need it to show in thread pool. Okay. What did I just say I'd go check? Oh, if we have an increase in logs and metrics. I'm just going to keep opening more of these. Okay, logs and metrics, last 15 minutes. I don't think so. Yeah, that's chill. Not discover DevTools. Do you have a write queue? Can't even induce the problem. Okay. Everybody's going. Pretty sure if we don't notify. think it's something like that. We'll find out. I don't really want to be notified this much, but it serves its purpose. Okay, so can't even induce hotspotting when I try. Well, induced historical hotspotting, which is exactly, by the time I as support see the case, usually it's this. If it's not this, then this column is like 5,000, 8,000, 10,000. At 10,000, you're going to be inducing 429ers, just because it's going to be thread pool rejecting. But we're not even inducing issues, and I want it to. Someday. Blah, blah, blah. Okay, so I think that earlier idea of making it smaller, maybe, ooh, wow. I did not like that. I think it's my computer not liking that. Hey, look. What is that? Cut shards and sort equals. Okay. Headers equals node index shard pride rep docs. What node was it? 0? Oh. Sort equals node index. Yay! Okay, so we got some more Elastic Cloud logs. That's what I was hoping for. Node 1 has this. Part of me just wonders, like, let's just move everybody over to node 2. 17,000. Yeah, let's do it. Cluster reroute. How do you run a cluster reroute? Oh, I got rid of those 2 node or index names. That makes sense. I thought I was done with them. I want this. I don't recognize that. I think I missed that earlier. Yeah. Okay, so I want that one. Who else was there? La la la. Monitoring. Kibana 8. Nope. That one. And it was. Ooh. Potentially also do that one. Needs file and removed first. Who are you? Are you the same one? Oh, I thought we removed replicas. I must be thinking of something else. Yeah, let's remove replicas again, I guess. Cloud logs, metric beat. That's what I was expecting. Oh, I was thinking of this one. Okay. So, let's just do our circle again. Get ilm explain nobody put settings index number of replicas 0 auto expand replicas I think it's null. What is the default for auto expand replicas? The default's to false. Awesome. Okay. And then do a get on settings. And it should now tell us number of shards. Okay, so this one's ready. Let's run that same. Oh, and it's stored up there. Okay, now let's do the next one. Sorry, I'm trying to like organize this so I remember. So do an ILM explain, it's not there. Do a settings update. Awesome. And just trying to reaffirm to myself what I actually think I've done. Okay, and then let's do that third one. Do it one more time. And let's decrease our refresh interval. That's another way to put the system in pain. Okay, so those should all now be single shard. Maybe do that by docs descending. Okay, so, ooh, too much. They're all shard 0 and primary. Okay, so these 4, let's force them all onto node 2. So a cluster reroute somewhere, I don't know, skip to the example. Skip to a console example. Nope, this one. I guess I should check real quick. I don't think I'm in this thread pool. Yeah. See, I want that 21,000. So I need to move. I need to do 3 moves. 3 moves? I didn't check. I literally pulled it up to check. Where are you? That one. Cat shards. Test is on 2. Nobody else is on 2. I want to move 1, 2, 3. Yeah. Just hold that for me, please. Okay. So I want to run 3 of these. And it's going to be moving this shard 0 from node 2. Node 2. I wonder if we have to turn off the allocation balance. Rebalance. What did that say? None or no? None. Okay. Hopefully that avoids my balancer automation helping me. Because I don't want it to. Okay, node 1. Ooh, also node 1. And then node 0. Acknowledge true. Awesome. Okay. What's cat recovery? Oh. These should be extremely fast, if not already completed. Let's find out. node 2. Excellent. Okay. So node 2 should be feeling some pressure once we start ingesting again. Node 2 is to 28%. I think we might end up needing to lower that. Find out. Let's just kick everything off again. Afterwards, if it's not working out, then we will figure it out. Okay. Let's keep it up. Okay. Well, let's go size ourselves down then. Trying to show ourselves the issue. 1 gigabyte, here we come. I think 1 gigabyte might, I think kicking off the plan may reset our shard settings. So we may have to go move everybody after again. Okay, let's watch that. Oh, you okay? 502. Did we take down Cabana? Oh, what kind of plan change did we induce? Cabana's unhealthy. I've always wanted to know, does the Cabana API status? It does pull while things are down. Man, that's so cool. Whose does it think is down though? It says it's available. Is the problem already over, or can you have both of those at the same time? The problem's already over. Cool. Hit enter then. One 101, 102. Uptime, so what is it trying to do? I needed cat recovery. So nobody's moving. Oh, okay. Node 0 already left, or is restarting. Go see. Node 0 is 1 gigabyte, but it should be coming up. My logs and metrics. Let's go look at that. I don't need less 1 hour. 7 minutes probably fine. Not that. What was it? Service? Service. Type on the Elasticsearch. La la la. Okay. It's figuring out shards. Oh, node 0 is already restarting? Good job, node 0. So 0's in. I'm hoping, yeah, it's like I was hoping all this would keep going while we were waiting. Oh, we queued! Oh, we queued! We did queue. We just barely queued, man. Oh, it did return. Okay. Ha ha ha. I don't want you. La la la. Yellow to green. Where are we? So node 2 is restarting. Hey, heat percent's pretty high. Is it staying high? It's not staying high. Oh. That's okay. We can try to force it. It overrode resources on node 1 and on 2. I don't know what that means. Okay, so node 2 should be coming up. Dev tools. Ooh. View details. No shard available. Excellent. That's because node 2 is restarting. And it has our shard. Because I didn't let it rebalance. Okay, so node 2 is back in cluster. That should be true. And its CPU is 100. Oh, man, I was hoping that'd stay. That'd be awesome. Okay. Let's go see where our nodes are. Or, sorry, where our shards are on our nodes. Cat shards test. It was dot monitoring. Was it dot metric B? Okay. Node 1, we didn't care. 0, we didn't care. Cabana, we didn't care. Okay, so everybody stayed where we wanted. And probably all of these failed. Let's just restart it. I don't care. Blub, blub, blub. Okay. Yay! Okay. I don't actually necessarily think we're going to get much better. Just because it's test and like Elasticsearch can take a lot. So we're going to use this, how little it is, for still saying, hey, we induced queuing. Yay, we did it. Okay, so again, we induced queuing because we were doing individual doc writes, which you generally should not do. You should always try to default to bulk. It's not one doc per bulk. It's usually like 500 docs per bulk. We just wanted to be able to induce this. So we have some thread pooling, and as we hit play, we should be seeing that that node is also over time going to continually be showing an increase on the completed side. So that is going to be good. And then I'm just trying to see what docs we're getting up to. Blah, blah, blah. Okay, let's see if we see any resource hotspotting. 75, does it say 75, 72, 63, 63, 66? Disk is up to 2%. Okay, let's go find out. For the JVM pressure, JVM memory pressure on node 2 is 55, so it's basically the same. Again, probably as close as we're gonna get on the example, which is chill. Okay, let's go look at doggies. Not that search, not that search. Less 1 hour. My search is taking a while. I kind of want that. That should be inducing pressure. I don't want a node to leave though. Aw. Node 2, did you go? Wait, node 2. Node 2, come back. I'm sorry. Node 2. Node 2 does not say it's exited. So I need to look at its logs and metrics, which would have made sense if I had not put the exact index in question on node 2. That's funny. All of these should be failing. Yeah. Ooh, unhealthy. Excellent. Once it recognizes it's unhealthy, it should be coming back here in a second. By a second, I mean like a couple of minutes or something. Yay! Node 2 CPU's 90. Does it stay there? 100. 98. Yes! Okay. When CPU is high, we poll node hot threads and ask who is doing that. And the answer I would have expected would be a right. It's generic. I don't know what generic means. Do you collapse? You don't collapse. Scroll past. Scroll past. Oh, that's the only one. Okay. Whatever generic means. Are you back? Yeah. Okay. We should probably move you off. Send you back to 0. As long as I can run, or as long as I can see that one, we should be able to keep on the rest of the party. Somewhere in here. Oh, we didn't even search for Elastic Cloud. Cloud logs is on 0. Excellent. Okay. So I think our node should be generally stable. Okay, so node 2 completed count reset, which also means it's uptime reset. So node 2 actually overwhelmed, which is excellent. That's exactly what you potentially see when you hotspot too suddenly, too fast. Ironically, I thought I was like underdoing it, but I overdid it. So let's go investigate that. So we know that node 2 exited, and so let's go look at ECE instance. Not instance, name, node name. I guess I should look for node. Node name. Let's filter into ECE2. I only really want, it restarted the last 15 minutes, but we can stop that refresh. Okay. Sorry, I forgot. Level? And then, I did not know critical was a thing. I thought it would say error. The state field in the response to the reroute API is deprecated. I think these are related, but I think there's going to be a lot of them. I don't want to see that. Elected as master. Who failed as master? Was node 2 master? Because that would have been ironic. I didn't look. Scroll? No scroll. That was it. Wow, we killed it so fast, it just straight up vanished. Vanished? Loaded module. Sorry, so it does initializing, initialize, starting, started. And so as we scroll down, I'm scrolling up. Okay, so the last log was started, and then somewhere under it, there would be starting. Oh, there's a second page. Closed. Stopped. That should be that somebody requested it. If that was 30 minutes ago, Let me... Master node disconnected. Yeah, that may have been our plan change. Blah, blah, blah. It's gonna be somewhere after this. Started. Oh. That was the earlier started. So it's coming up, it's coming up. Publish address, so it should be in the cluster. Master node change, so it is in the cluster. Wow, we like killed it so fast it didn't even tell us what was wrong. I'm so proud of us, good job. Okay, let's go take a look real quick. Let's make sure, I think our shards are gonna be where we think they are. Excellent. Just in case that plan, I'm gonna hit this again. Okay, let's do it a second time, just so that I have it running in case we end up wanting to see. I'm only gonna do 2 right now because poor little thing's only 1 GB and it allocates like half that RAM. But let's start getting node 2 to chug back up. I'm trying to get higher. At some point, we're just going to pretend that these disk percents are a lot higher, and we're going to investigate that. But let's go talk through this hotspotting guide. So this hotspotting guide usually ends up applying at scale, right? Like usually, for example, you'll go spin up an Elastic agent and say it's like a custom integration, and the custom integration just defaults an index to 1 primary, 1 replica. You're going to directly end up with what we're kind of inducing right here, where 2 of the 3 nodes are ingesting a whole bunch, and that 3rd node is kind of sitting idle. That would be cold spotting, right? But like, consider a different situation. Consider you have 6 hot nodes. You're only ingesting into 2 of 6. So paying for a lot of hardware for the majority of it not doing anything, right? So our example kind of applies across all ingest methods that you can set up, particularly on that shard distribution level. So for us, what we ended up kind of showing, kind of not, is under cat nodes, we saw the heap percent, maybe a little bit higher, maybe a little not. Right now, we're getting our disk use percent up to like 1%. We'll go review that here in a second. Our CPU did get high, and anytime CPU is high, I think it's this high CPU doc. It like tells you, right? Like you go run cat nodes, that's how you discover it, and then afterwards you go run hot threads. That's exactly what we did, which is awesome. Our hot thread run, I was expecting was gonna show us write, which would just reflect the write queues that we were inducing. However, because the node was already past restart and trying to rejoin the cluster, it said generic. That's chill, right? But this ends up discussing like if you need to scale your cluster or anything. And then I just filed yesterday that it also expands in order to also discuss hotspotting. Yeah. So that CPU chart or information is also going to update here in a little bit. Okay, so we induced that. The second part of what we induced, cat allocation side, we did induce. Yay for us. Haven't super induced this. Or sorry, we induced it like in super baby terms, right? Like it was almost 0% compared to 1%. Eventually that'll get to 2%. Usually when we end up seeing this with customers, kind of like this shows, like it's more like somebody's only 19% and everybody else is sitting at like 52, right? That's fair. So we've kind of induced that. And then index level, this is what we've been trying to see is that cat thread pool. I think we got to like 9. Yay. But also that cat thread pool. Oh, that wasn't cat thread pool. That cat thread pool, especially looking at historical, should be starting to get higher numbers. Blah, blah. That node's staying in. So let's induce some more. Node 1 is increasing. Why is node 1 increasing? You ran cat shards again. I wanted this. Shards. Guess that's chill. Node 1 can ingest if it wants. Okay, so we got ish to a write queue. Okay, so kind of ish seeing what we see now. Now the conversation becomes pretending we didn't know how we did it, which we obviously do. How would we go investigate? So in particular, we do see that node 2 has 11,000 of completed queue. To be fair, that's since node uptime, right? So that could have been historical noise or it could be current noise. Usually because of that, you like pull cat thread pools like over 5 minutes or something. And here we'd say, let's pretend, right? Like you kind of can see it, that completed column is growing a lot faster than the other columns. So to that extent, we know that it's current shards on that current node that are inducing the problem. So at that point, we'd say, let's go run cat shards. I'm going to do this in the API console because it's easier to search. Run that and output the index name and node 2. Oh, is it not called index? Okay, so these are all of the shards sitting on the node. And then usually it's the ones that have the highest docs count. Docs descending. Is it not called index? Oh, the equals true. Okay, so here we'd see the best bet to go test is test, right? The second best bet, it looks like it would be 2 of them, which ironically are the ones we're dealing with, that are 20 and 30,000. Those combined would be test, right? But again, test is kind of like the clear leader, and then the other ones are residuals ignorable. So at this point, we'd say, hey, like, how is test doing, right? So when you contact support and you're like, hey, like, I have hotspotting, and support's like, oh, hey, like, it's node 2. It's a little unfair. It has a higher thread pool. It has some potential cat nodes issues on it. They'd say, okay, looking at cat shards, it looks like the one sitting on node 2 majorly is test. So let's go look at, if I do a cat shards of test, question mark b equals true, I as support automatically am like, wait, it's one shard, what's happening, right? And then I cross compare that to cat nodes. Oh, sorry. I cross compare that to, if I run that index settings, what data tier is it sitting on, right? And this one says it's sitting on data content. So for cat nodes, data content under the role is the S, right? So there's 3 nodes that potentially could be sitting on, and then it's only sitting on 1 of 3 nodes. So that does not sound groovy. And so usually at this point, support would say, like, for that test, do a settings update index in order to number of replicas, in order to get the shard count even across the 3 nodes. So the reason for this, I never remember where it officially is. Let's go look it up together. Ingest rejections. We didn't induce any ingest rejections. How sad is that? Blah, blah, blah. Scroll down. Okay, so this is Elasticsearch's write model from one of their PDF diagrams. So when we go to do that literal write, like the HTTP request is coming into the coordinator node, we didn't run any ingest pipelines, and then it's going to enter the data node. And note right here, it's actually doing its write request like right here. But it actually split the replica out before that. So this means primaries and replicas actually write to disk separate from each other. It's not that the primary writes to disk and then copies over to the replica afterwards. But obviously Elasticsearch keeps everything in sync, and probably SHA or hash confirms everything's the same. But the implication of that is that when you have uneven shards, all you potentially have to do is add on replicas in order to make that even across the 3 nodes. So right here, test settings, replicas 2, I'm going to hit enter, and then I'm going to come back wherever I ran cat shards, and now we see 2 replicas are initializing, and because replicas avoid the primaries, or sorry, because replicas spread out across the nodes, we automatically spread out 0, 1, and 2, where 2 is our primary. So now that ingest is going to start hitting all 3 pretty evenly. Same spirit, if you contact support, they're gonna end up telling you, like, hey, those other 2 ones probably also should have that same conversation applied to them, that you should increase replicas. Let's take this second example, because it's a data stream, as our opportunity to say, what if I didn't want to increase replicas, what if I wanted to increase primaries? So the reason you would do this is if it is high ingest, Elasticsearch recommends Elasticsearch shard sizing? Yeah, size your shards. So Elasticsearch recommends that shards work best between 10 and 50 gigabytes. So our example is a test, right? But those shards are crazy small right now. That's obviously fine while you're writing, right? It's the final state that they eventually run into. So normally when you contact support, you have to deal with, like, my shards are above 50, how do I get them back down? We're actually the opposite. Or sorry, yeah, we're the opposite. We're saying, like, our shards are a little too small, how do we get them bigger? Let's just pretend, though, that we had the other side of the problem. We would know that we need to go fix these historical stuff, but the question becomes, how do you fix it going forward? So let's pretend that this index had a high disk amount, right? And that we potentially add back in replicas, but we wanted to go split that index from 1 primary shard out into 3 primary shards. You can recognize data stream indices because they preface with a .ds. So we know that the rest of this is actually a data stream name. No such index found, obviously. Oh, sorry. I included everything at the end. Also not found. We're gonna get close. 8.5. Blah, blah, blah. Oh, sorry, 8.15. Okay, so our data stream exists, and right now we only have that 1 index. I think that's because I removed ILM from the index level. So adding ILM, if it didn't exist, would be an excellent step. Obviously for us, it looks like we should add back metric beat in. However, if you want to modify data stream primary shards, that's considered a static setting. So we want to modify a data stream, add a new, change an existing static setting. Okay. They can only be set when the backing index is created, blah, blah, blah. I'm pretty sure we want to change the associated template and then afterwards do a rollover. So who is our backing template? Whoa. Does it say that a put is allowed? Yes. Okay. Thank goodness. And how does that format? I think we only want to edit this template. Template settings. Refresh, mapping. I don't care about mapping. Okay, let's see if that's allowed. Requires index patterns. Oh, it may require everything then. Let's go copy. just have, oh, template. Copy. Yeah, we can add this back in. I don't think I care about that. So I need an index pattern. That's outside of the template. What else did you want? To be fair, at this point, I'm probably just going to keep hitting submit until it lets me. Priority null. I obviously missed something. Priority 150, not a comma. Ta-da! Okay, and then we need to do a post rollover. In which case, getting the data stream again should tell us that there's a new one. Last one on the list is the newest one, and this one, if we do settings, should tell us there's 3 shards. Awesome. Okay, and also because we did a rollover, all of the ingest is going to be pointing to that latest. So now we fixed the second one. Before I forget, let's just go make sure node 2's up. Awesome. Okay, so because we added in all of those replicas, our disk use % also automatically ended up fixing. Backtracking that thought here a little bit, like the disk used being uneven, especially if shard counts are even, is frequently how support ends up also diagnosing, or I should say suspecting, that this problem is occurring. Obviously, you kind of have to dig into cat shards and cross-correlating cat shards over to cat nodes. Okay, so at that point, I'm pretty sure we've shown hotspotting, we've shown it on an index level. If you want to see historical, you start diving into index and shard stats. We're not going to do that. If we had actually had long-running tests, which we didn't, we would have dived into the cat tasks. Okay, so at this point, the question becomes, we ish know how to detect it, but how do we avoid it going forward, and in general, and like how do we like introspect when this problem's happening, right? The very first part is this index level and the base index settings that you're setting, right? You should be very cognizant of your sharding strategy against your hardware per data tier, right? So where we said like our shards should be 3 shards if our nodes for that data tier are also 3. Or, sorry, shards in the sense of like primaries plus replicas together. We just solved it 2 different ways, right? 1 primary, 2 replicas, or 3 primaries, it was 0 replicas, but it could have been 2 replicas, right? So that's one way. The second one, though, is Elasticsearch 8.6, desired balance. Like, Elasticsearch has super improved this system and do generally hugely recommend upgrading to or past 8.6 just because it has that desired balance, which does take into account data stream writes, and also disk usage, like especially that data stream write side, right? Like I just barely showed you on 8.15, and we had to bend over backwards in order to induce the issue, right? On lower clusters, it's potentially easier to induce, but just generally stating, things above 8.6 really do avoid the problem, which is exactly what we want until I try to show a troubleshooting video, right? So 8.6, recommend getting there or higher. If you can't, or until you can, the exact thing we just did. You fix your sharding strategy, or last resort, you are, wrong tab, coming here and you are doing the manual cluster reroutes yourself. That is kind of the only option you have. The last part is a thing to potentially look out for, which I'll induce here real quick. I'll induce it real quick just so you guys can see it. So Kibana is helpful. So when you click into these different UIs, it goes and generates backend indices for you. So I'm just clicking into enterprise search, into observability, and into security. And it's loading. And it's going to be loading for a little bit. And then I'm going to come back to DevTools and I'm going to show you cat indices. Now cat indices was small before. Ooh, that's like way too much. Let's just say index and docs count. If I knew how to write that request correctly. Okay. And sort equals index and expand wildcards equals all. Okay, so by clicking into those different Kibana UIs, Kibana attempted to be helpful and it created various indices for me. So it created some AI assistant indices. These are all from that security sim UI. This is the observability right there, blah, blah, blah. It looks like, I think I'd have to enable enterprise search for it to show. So if you don't intend to use those features, any end user clicking into those UIs could potentially induce these indices. These indices aren't actually a problem, right? Like, they're fine. But let's say with these as our example, hypothetically, you are before 8.6. These indices being empty still satisfy that shard balancing, right? And so they are potentially worth before 8.6 going through and deleting. Also, I think it's ILM rollover, Elasticsearch. Oh, Elasticsearch if I could spell it. Okay, so the second one is, I think it's around 8.7. But Elasticsearch ILM team induced a min age, somewhere in here it tells you, if min docs is 0, it's not going to roll over. That's not true in earlier versions. Let's find out when that became true. Max min, oh, before I thought it was. This is fun. Now we're all gonna find out how I found out. Okay, it introduced 8.4. Okay, so the reason for this is 8.4, before when you would create indices. So again, these as examples, but let's say you set up a data stream before 8.4 and set it to roll over every hour. It created a lot of empty indices potentially, right? And those counted to the shard balancing. At that point, we would say like you want to get above 8.4. And secondly, you want to go delete out all of those empty indices. Again, hugely highlighting. Not a concern necessarily, and not a problem after 8.6, but definitely a problem before and historically, which is why we're having this discussion and is why that troubleshooting doc exists. So if you've made it to this part, thanks for hanging out with me. It's been awesome. At this point, to the extent that we can, we have shown hotspotting. Just knowing problems usually happen at scale. They usually happen during load testing, or if like new services go live in production, that's usually the moment you find these. So load testing your system, looking at your shard strategy, and getting above 8.6 are all hugely beneficial to avoid this conversation even coming up. Anyway, thanks all. I hope you have a great weekend.